Fourth, solid angle. The three-dimensional angle, a sort of cone formed by intersection of three faces, is called a solid angle. Just look at one of the corners of your room. The following figure will illustrate all the points we have discussed so far. Thus, for the time being, if you consider your room as a cube, then it has faces equal to 6, 4 walls, 1 floor and 1 ceiling, edges equal to 12, 4 vertical, 4 on the floor and 4 on the ceiling. Solid angles equal to 8. There are 4 corners on the ceiling and 4 on the floor. The fifth point is very important. That's about symmetry. An object has symmetry if some operation is carried out on it which converts it into itself. That operation is called element of symmetry. There are following 3 types of elements of symmetry that we wish to study with respect to a cubical crystal. A. Plane of symmetry. A plane which divides the crystal into 2 parts such that one is the mirror image of the other is called a plane of symmetry. For a cube, there are 3 rectangular and 6 diagonal plane of symmetry. A rectangular plane is obtained by bifurcating the length or breadth or height of the cube equally. And the diagonal plane is obtained by joining the diagonally opposite edges. Since there are 12 edges in a cube, hence there must be 6 such planes. These planes are represented, for example, in the following figures. B. Axis of symmetry. A line about which, if the crystal is rotated, it will give the same appearance more than once in one complete rotation, is called an axis of symmetry. For a cubical crystal, there are following 3 types of axes of symmetry. First, dyad, also known as an axis of two-fold symmetry. It is obtained by joining centers of diagonally opposite edges. Since there are 12 edges in a cube, hence it will have 6 dyads. If a cube is rotated about it, the same figure appears after 100-degree rotation. Second, triad, also known as axis of three-fold symmetry. It is obtained by joining diagonally opposite solid angles. Since there are 8 solid angles at the corners in a cube, hence there must be 4 triads in it. If the cube is rotated about this axis, then the same figure must appear after a rotation of 120 degrees. Third, tetrad, also known as axis of four-fold symmetry. It is obtained by joining centers of opposite faces. Since there are 6 faces in a cube, Hence there must be 3 tetrads in it. The following figure shows each one of the above axes in a cube with center of symmetry also. Thus a cube has total axis of symmetry as 6 diodes plus 4 triads plus 3 tetrads, so that total comes out to be 13. See, center of symmetry. A point within the crystal that any line drawn through it intersects the opposite faces at equal distances in both the directions, and so will be the cases for diagonally opposite edges and solid angles, is called center of symmetry. Remember, a crystal may have many planes and axes of symmetry, but it cannot have more than one center of symmetry. Therefore, the total number of elements of symmetry for a cube or cubical crystal will be planes equal to 9, axes equal to 13, center equal to 1, so that total is equal to 23. Now we come to the next major article,